On this episode of Assignment Discovery, learn about genetics and why you should never underestimate the power of genes. Whether they're solving crimes or playing with dollies, see how scientists are taking genetics to new levels. Find out how this pig could be a lifesaver and why this cow is worth $1.5 million. And learn more about genes online at discoveryschool.com. Consider this before viewing Understanding the Power of Genes, Part 1. What do you know about the applications of genetics? What have you heard about Dolly, the cloned sheep? Watch for the ways that a clone is made and how the procedure is being used in other areas of genetic engineering. Pay special attention to the possible benefits and drawbacks of this new technology.
For the first time in history, it is within our power to intervene in the design of life. New breakthroughs in genetics are bringing us closer and closer to what used to be called science fiction. The age of genetics is fast approaching. The ability to clone animals, grow organs, and cheat death is within our grasp. Will we duplicate ourselves, alter our genes, and even dare to design immortality? It's science that could revolutionize the world.
In the next 100 years, we're going to have an incredible understanding of genetics. Inevitably, we're going to have sequence information from many different species and many different individuals. It is information that, to me, is probably one of the most important breakthroughs in human history.
With the advent of super-powerful computers, a handful of scientists are now able to explore the inner space of our genetic code as never before.
We've now developed telescopes that let us look at DNA at an incredible level of detail. And within a few years, we're going to know the sequence of 3 billion bases of DNA. Once you have that information, there's a lot more interest in genes because now we know what genes are. We know what all of the genes are.
It's information that redefines our concept of mortality and may extend our life indefinitely.
I don't think that people are born to die. We have in ourselves the fundamental essence of what a human being is, or any animal or plant or living thing is an immortal molecule, DNA.
In the beginning, the very beginning, was the first life, known as the original ancestor. It was a one-celled being which contained genes in short strings of DNA. It had a miraculous ability to make rough copies of itself. The molecule which made up the DNA of that original ancestor has passed through 3,000 million individuals to become dinosaurs, or trees, or chimps, or even people. The living world has infinite variety because every time the DNA copies itself, it mutates or changes slightly. This is evolution.
DNA is a molecule that has two parts to it. When it divides, the two strands separate, and two new strands are created. You can't tell what was old and what was new. So it is, in fact, the same molecule. That process has gone on for 4 billion years. The DNA that's in you, the DNA that's in me, has a direct trace right back to that molecule that was on Earth 4 billion years ago. And you can't say that either this molecule or this one was the original.
Every DNA molecule forms a twisted ladder with rungs of 4 specifically paired chemical bases. Adenine pairs with thymine, and guanine with cytosine. The chemicals dictate the creation of different proteins, which influence everything from eye color to IQ. Recent breakthroughs in the mechanics of genetics have revolutionized how criminal investigations are conducted, even when the case is decades old. In 1954, Marilyn Shepard was murdered in cold blood. It was a crime that captured worldwide attention and spawned the TV series The Fugitive. If the genetic technology of today had been available then, the man accused of the murder, her husband, would have met a different fate.
All of Cleveland awaits an answer to the question, who murdered Marilyn Shepard?
It was July 4th, 1954. Sam Shepard had guests over. He had, I guess, a few glasses of wine. He went to sleep under the stairs. His wife went to bed. A visitor came by, thinking Sam was away because he was not in plain view. And Sam heard some noise, got up, grappled with somebody. He called him a bushy-haired man.
The jury did not believe Sam Shepard's story. He was convicted and served 10 years in a state penitentiary for the murder of his wife. Then, in 1966, Shepard appealed his conviction with the help of a young trial lawyer, F. Lee Bailey.
I'm confident that Dr. Sam will never be retried because the state does not now have a case it never did have.
In fact, Sam Shepard was retried, but Bailey was able to get him acquitted on a technicality. Still, many people believed him to be guilty. He lived under a cloud of suspicion until his death in 1970. His son was determined to prove his innocence, but things looked grim till science began solving crimes.
DNA is a silent witness. It doesn't talk, but the scientist's job is to find out the facts, what the evidence tells.
Dr. Mohammed Tahir, a pioneer in DNA technology, was asked to help solve Marilyn Shepard's murder. It's the oldest case to be reopened using DNA evidence. To make the case, Tahir needed to compare DNA from the blood-stained items at the crime scene to a sample of Sam Shepard's DNA, but Shepard was dead and buried. Where could they get the DNA they needed? Tahir came up with an ingenious way to solve the problem. He scraped the back of old postage stamps on love letters that Shepard had mailed to his wife in the mid-1940s. It was a tedious process that took hundreds of hours. Once a DNA sample is obtained, it is analyzed by looking at an X-ray of it. The black bands show the patterns of the chemicals that make up the rungs of the DNA ladder. This individual fragment of DNA was found at a rape. This is a DNA sample from a suspect. If the two match, there is virtually no chance for error as long as the sample is not damaged or contaminated. In the Shepard case, the DNA sample was insufficient to be definitive, but there was enough evidence to warrant the next step. The authorities exhumed Shepard's body and Tahir gathered more DNA. When it was compared to the DNA from the evidence, Tahir confirmed that there was genetic material at the crime scene that did not match either Sam or Marilyn. That could only mean one thing.
In this case, the DNA found on the wood chip and on the Sam's pants did not belong to Marilyn Shepard, and neither it does belong to Sam Shepard. It has to come from somebody else.
DNA evidence properly handled, tests properly conducted, is extremely reliable. The odds are astronomical that it was or was not this person. So it is a definitive way of excluding people, and that has been its principal benefit.
DNA evidence began to play a vital role in criminal investigations beginning in the early 80s. It's now standard police procedure that with every violent crime, items from the scene are meticulously scraped for remnants of DNA. The FBI considers DNA evidence its most powerful tool, and now they are using it in a new way. In 1994, they developed a new software program they dubbed CODIS, which greatly increases the numbers of DNA matches nationwide.
In the past, typically laboratories match a known sample against something they found at a crime scene. Looking at various points on that evidence, they say yes, the known sample matches the unknown, or it doesn't match. That can be on a bullet, a cartridge casing, a fingerprint. The process is the same. What CODIS does is it adds a little bit extra. You don't need to have that known sample to solve a crime with CODIS. You go in there and search DNA evidence found at a crime scene, and without having any known samples, you can search the database and get a list of possible contributors of that sample.
CODIS has led to the conviction of more than 300 criminals, including these.
We think ultimately CODIS is going to be just like fingerprints. Obviously DNA, there's much more you can do with it than just a fingerprint, but for law enforcement purposes, it's used just like conventional fingerprints.
As the technology becomes cheaper, it will become more widespread. Someday, the FBI may only need to click a mouse to catch a thief. The only FBI agents more technically advanced are the fictional ones. Science fiction often unknowingly predicts the future. The X-Files are no exception.
What I like about being a scientist and liking science fiction is that so much of it is now becoming true. It's like, when does it stop being science fiction and start being science?
No one is quite sure where the genetic breakthroughs of today will lead, but one thing is already clear. Fact is overtaking fiction.
Cloning used to be science fiction. And now all of a sudden, there's sheep cloned, there's cows cloned. You know, there will be cloned cows in our future.
There already have been, and just by looking, it's hard to tell an average cow from a clone. But one way to tell them apart is by the price tag. An average dairy cow costs $1,100. Mr. Jefferson, the newest creation of PPL Therapeutics, is worth $1.5 million.
If you go back about 3 or 4 years, there essentially wasn't any competition. All of a sudden now, though, with the ability to clone from cells that can be easily cultured and cells that can be genetically modified, this has opened up the field to many different applications with tremendous commercial potential. We've essentially, within the last year, have developed a technique that could be key in the development of what might be $10, $20 billion industries in the future.
It all started with a sheep named Dolly. Dolly was the world's first clone created from an adult cell of a living animal. Before Dolly, geneticists believed that once a cell becomes specialized, like a skin cell or a mammary cell, the genetic instructions for creating another life were permanently switched off. The creators of Dolly forced cells into hibernation by starving them of some nutrients. This starvation essentially took the cell's genetic material backwards in time, into a state that could create life. It was a moment that altered our very notion of life and how it can be manipulated.
It really turned things on its head because all the data suggested that this should not work. And all of a sudden you see that it happened and it has worked, and it really makes you rethink the entire system and what's going on.
So how do you make a clone? It starts by gathering DNA from fetal cells, embryonic cells, or even the skin of adult animals. Specific cloning techniques are changing fast, but the results are the same. One of the most successful cloning methods happens in a room that is kept at 110 degrees Fahrenheit, the same temperature as a cow's uterus. The actual creation of the clone happens in a petri dish, under the powerful lens of a microscope. With the guiding arms of the micromanipulator, the nucleus of an egg cell is sucked out, creating an egg that has no genetic instructions. Then the DNA from another cell is inserted. a jolt of electricity is used to jumpstart the genetic material into creating life. But to make it into the world, the clones need the help of a surrogate mother.
In this device right here is a transgenic embryo that we made in the laboratory last week. And also designed to go along with this unit is a plastic sheath. Now this device will be used to deliver the embryo up into the uterus of the cow.
After the transfer, the growing clones are carefully monitored. Only 1 in every 95 pregnancies results in a clone that actually hits the ground.
That's a real solid, healthy 2.5-month pregnancy. Looks very good. Probably one of the neatest things to observe is the heart beating.
This unborn fetus is a genetically altered cow clone. If it is taken to full term, it will be an offspring of genetic engineering. Geneticists have gone beyond sexual reproduction and invented a new way of conceiving life.
To tell you the truth, I've never once ever thought that I was a creator. I feel more like a manipulator of taking a very complex, a very beautiful system and manipulating it in ways that it can be of benefit to mankind.
Scientists may not feel all-powerful in their work, but technically they are creating some new life forms. DNA from one species can now be spliced into another, making genetically altered animals called transgenics.
This is the breakthrough that the whole cloning area has really been waiting for to commercialize the effort, and because we can make large numbers of identicals, but we can also do the genetic modifications.
All those cattle are potential living drug factories. Geneticists are experimenting with adding a human gene to a cow's DNA. The result is a custom-made cow with medicines in its milk. The cow will give milk with human proteins in it, the same human proteins that are used to create some rare and life-saving medicines for burn victims and cystic fibrosis and hemophilia patients. The designer cow could make these super expensive and hard-to-get medicines more available. They could also create a billion-dollar business. The proverbial cash cow. And that's not all they may be able to do with humanized cow's milk. This is Rosie, and she is the first step toward making human milk for babies that come from cows, not mom.
Well, Rosie's a very special cow. She's about 20 months old, and she's the first cow that's producing a human protein in her milk. She's transgenic for human alpha-lactalbumin. This is a milk protein that's not normally present in the cow, and it's the first step towards humanizing cow's milk. Ultimately, you could envision eliminating all the cow milk proteins and replacing them with human milk proteins, milking a cow and having human milk come out.
And if they can make just one of these cows, they should be able to make millions of these cows by cloning.
We can get literally billions of these cells, and we can do all sorts of things with those in culture. And you look at the petri dish full of these, 100 million cells, and you think, gee, this is quite a large herd of cattle here, because we can theoretically turn every one of those into a cow.
The medical potential alone is awesome. Every year, over 55,000 people are waitlisted for an organ transplant that could save their life. Transgenic pigs could be the organ donors of tomorrow. This pig is being implanted with genetically engineered embryos. Their creators hope they will grow hearts that could be compatible with the human body. Before a transplant could take place, however, there are many obstacles to overcome, not the least of which is the danger of introducing foreign viruses into the human race. Every time we tinker with nature's design, there are unknown consequences. Neil First, known to some as the father of cloning, has been dealing with genetic controversies since he cloned the first mammal from an embryonic cell 10 years ago.
Ethical lines get drawn for every person a little differently. Collectively, we don't want to pass laws or allow situations where people have free license to do something willy-nilly or without a compassionate approach. But if an individual needs something, we're a very compassionate society, and we very quickly jump to that and say, we would like to help them.
At his lab at the University of Wisconsin, he is pushing the boundaries of cloning even further. Using the borrowed bits from an array of different animals, his team has reprogrammed cow eggs to create the embryos of other animals. It's called cross-species cloning.
So if that donor cell is from a pig or a primate, what's going to come out of that is a pig or a primate. It's not going to be half pig, half cow, as some people, I think, have thought about that. And it'll be a complete pig or a complete primate.
First uses the eggs of one species as a universal recipient for the DNA of another species. If this cloning technique is perfected, some of the world's rarest animals could be saved. There are about 1,000 giant pandas left in the world. Efforts to breed them in captivity have met with limited success.
Good boy. Giant pandas aren't that easy to breed, even in the wild. They are only in heat for maybe 3 or 4 days out of the year. They're solitary, so if they don't come together and breed within those 3 days, that's a year without a giant panda.
What if cloning could bring them back from the brink of extinction? Gathering DNA samples from endangered animals today could ensure the future survival of a species.
I do believe that we should absolutely and unquestionably be taking cell samples from any species that might be in danger of going extinct, because it is so easy to take cell culture, and we now know that that is capable of giving rise to a complete new individual.
It's already happening. Scientists in China have gathered DNA from a panda with plans to create the world's first panda clone. But something even more mind-boggling could be on the horizon. Some scientists believe that they can even clone from ancient DNA. No one's creating a real Jurassic Park yet, but they may be getting closer.
My personal interest is more in trying to resurrect extinct species as opposed to the endangered ones. And that is something that I think is very interesting. And as I talk to people, as kind of, it's more of a hobby than anything very realistic.
Now that you've seen Understanding the Power of Genes, Part 1, talk about this. Genetic evidence is currently being used in criminal investigations. Weigh the pros and cons of using this type of evidence in court. Why do some people fear the use of genetic identification as a crime-solving technique? Now try this. Research one of the latest advances in cloning or any other type of genetic engineering. Design, write, and illustrate a brochure on this cutting-edge technology. Log on to discoveryschool.com for curriculum materials and resources to support Understanding the Power of Genes. To learn more, Assignment Discovery suggests Genetics: Unlocking the Secrets of Life by Nathan Asen. Consider this before viewing Understanding the Power of Genes, Part 2. What do you know about identical twins? Why are they so important in the study of human behavior? As you watch the documentary, pay attention to the importance of environment and genetics in determining personality. Which do you think plays the bigger role? Assignment Discovery now presents Understanding the Power of Genes, Part 2.
maybe it will be that in the future, pieces of skin from a just born baby will be taken and frozen, and that will be used for cloning later.
I think if a technology gets developed and is available, it will be used. So it won't surprise me at all if somebody clones a human being.
It's a hot topic and a hot potato. But has it already been done?
People seem to have this fear of cloning. Lots of people seem to have it. I don't have the slightest fear. It doesn't bother me at all. I think it's just completely overblown.
Twins are the clones that walk among us. Identical twins have identical DNA. But to make an exact copy of a human is not just a matter of genetics. We're far too complex for that.
The whole issue of cloning is kind of a pseudo issue. And I don't think these people would be marching in step and be carbon copies of each other. There's clearly some very important prenatal influences, birth influences, and then unique experiences that each individual has as they're growing up. So these, even if we, for some reason, were to produce clones, they'd all be special people in their own right.
I guess we've got the look-alike blues. You're looking like me, I'm looking like you.
The clones of nature are rare. Only 4 in 1,000 births result in identical twins. Over 20 years ago, these anomalies of nature captured the attention of psychologist Thomas Bouchard.
They just really grip me. It's just so striking. For example, these 94-year-old ladies. Look at it. 94-year-olds, they got the wrinkles in the same place. I mean, it's just stunning.
There's nothing that we can do. We were born that way. I'm looking like you. You look like me too. 'Cause we are.
It's hard to look at twins and not question what influence genes play in making us who we are. Are we products of environment or biology? In 1979, Bouchard launched a groundbreaking study of identical twins separated at birth. They are almost perfect genetic subjects.
The advantage of identical twins reared apart is that they grow up in separate families, and they can't be treated as alike as twins who grow up in the same family. The similarities are sufficiently stunning if you run into such twins. It's hard not to believe that there can't be some genetic effects.
Bouchard's latest discoveries are Debbie and Sharon. At birth, they were adopted into different homes, and for 45 years they lived totally separate lives, unaware of the other's existence. In the fall of 1997, they met for the first time at the airport in Hartford, Connecticut.
And when we saw each other, we were expecting, like I was expecting her in curly hair, and she was expecting me in straight hair. So initially, from far away, we didn't think we looked alike, and it's like, oh, that's her.
And so I thought, if we weren't identical, we would have like nothing in common, and we just wouldn't have it, I'd say, well, we'll look at each other and go, oh, hi, how are you? Hi. And then like, she could just go back on the plane.
We hug and we kind of look up and down. It's like, oh, yeah, we are the same size and, blonde and small. And when our eyes locked on our faces, it was like too intense.
And we go, oh my God, because it was the same, we knew it was the same face.
Of course, Sharon and Debbie share physical looks, but what is uncanny is the similarity in their mannerisms and preferences, given that they grew up in totally different worlds. It points rather convincingly to genes as the source of these idiosyncrasies.
For cars, I like white.
For a car, it would be white, because white's the safest.
Like clothes-wise, I probably like blue, like navy.
Like in clothing, I would tend to go to navy, maybe.
Certain like couple of bridges that I don't like.
Mostly high bridges, especially where you can't kind of see the water on either side. There's the worst to me.
But such quirks are unmeasurable from a scientific standpoint.
guess I feel.
Bouchard was able to test for many other traits, however, and found that twins reared apart show about 50% similarities in IQ and personality tests.
It's like a blessing.
Genes don't just shape behavior. They shape behavior in environments. Individuals need to be exposed to environments. They need to learn. They have to develop preferences. So the old idea is that somehow or other genes just fix things like eye color or hair color simply don't apply for behavior. What the genes must do is sort of bias our learning, bias our preferences, and then we express those preferences and we learn things. And identical twins, whether reared apart or reared together, because they have similar biases, tend to pick up similar traits and characteristics and do similar things. So it's not determined in some deterministic way that, all mechanical. Not at all. Exposure to the environment and learning is absolutely necessary. People think, identical twins, carbon copies of each other. Not so.
Twins, like all of us, are products of nature and nurture. But without a complete chemical map of our genetic makeup, the reasons for human behavior are still the subject of speculation.
Well, actually, there's no single gene for any of these things. If it were that way, I think it'd be an easy problem to solve and find out what the gene is. There's so little knowledge about how genes specifically influence behavior that we're really at a point where one could probably make some fundamental discoveries. And things may be different than what we think.
But what about the rest of us? What makes some of us want to jump while others prefer to remain safely on the ground? Some scientists believe such character traits are in the genes we inherit.
Yeah, I guess I am a risk taker. I mean, if someone dares me to do something, I gotta do it. I can't say, no, I'm not gonna do that. My younger brother is definitely a dare taker. I mean, I think he's worse than I am. And I guess we both get it from my mom.
Some geneticists believe that genes may predispose us to act certain ways, even when it comes to something like taking risks. Dr. Dean Hamer is trying to find the link between genes and how they affect behavior.
All that genes do is to code for proteins, and all the proteins do is to control chemical reactions inside the brain. So there is no gene that says go bungee jumping or jump off the high dive or smoke a cigarette. The genes simply alter our brain chemistry in rather subtle ways.
To research what Hamer calls the novelty-seeking gene, he compares the behavior of siblings and their DNA.
We're the O'Neill family, and I'm Tommy. This is Johnny. That's Paul, and that's Joey.
Suppose that we had two brothers who were at a swimming pool. Well, if one of the brothers decided to go off the high dive and jump into the water, maybe do a flip on the way down, he would probably have the novelty-seeking gene. That makes his brain respond to dopamine, which is released when you do a novel experience, in a positive way, and he would feel pleasure from that. If the other brother decided not to go off the high dive and to go down the ladder instead, he probably wouldn't have the novelty-seeking gene, but he might have the anxiety gene. That gene controls serotonin, and when he did that experience, he would get a flash of serotonin that would make his brain feel very bad, would feel anxious and worried, and so he would be less likely to dive off the high dive. So just by looking at those two genes, we could tell something about whether or not people get excitement from a new activity like high diving, or whether that same activity makes them feel anxious. And it's all because their genes are a little bit different. That makes their brain chemistry just a little bit different as well.
In addition to the novelty-seeking gene, scientists have identified genes that cause behaviors like addiction and anxiety. But the temptation to tamper with so-called undesirable genes could open a Pandora's box.
But I also think it would be a mistake to take the research too far. I think it would be a mistake to try and change people's genes. All of these genes do multiple different things.
With every new genetic discovery comes new choices for our world. By the year 2005, the Human Genome Project will have mapped our entire DNA sequence. This ambitious government scheme will publish the complete sequence of the 3,000 million letters in the human DNA code. As the Human Genome Project races towards completion, more and more genes are being discovered daily. Nearly 1,000 disease-causing genes have already been mapped.
Now, from a practical point of view, it's got limited use. Because once you have the information, you don't know how they're used. You don't know how they change in normal and abnormal situations. It's like saying, okay, now I have a library, better start reading. Okay, but you better have the library first. There's a second part of the Human Genome Project, which defines human beings and living systems in terms of inherited differences. What makes a difference between you and me? What makes a difference between somebody who gets sickle cell anemia and somebody who doesn't? What makes a difference between somebody who's going to get ovarian or prostate cancer at a high probability and somebody who doesn't?
There are thought to be some 4,000 diseases that are directly inherited, and countless others in which genes play an indirect role. Margaret Baker suffers from the genetic disease alopecia areata, a condition that affects 2.5 million people in the United States.
With me, it started right towards the back of my head, near my crown, in a small $50, and it spread gradually. And the hair just, it came out in patches, and that's probably the most traumatic part.
Today, she lives and works in New York City as a model. Unhindered by the wigs of the past, it's her own way of celebrating her genetic difference.
People search all their life for uniqueness, inside or out. And at 18, I realized, gosh, I have this, and I've been hiding it all my life. I can't believe it. I can't wait to get out and show the world. And it sounds corny, but it feels like such a blessing.
Hi, it's nice to meet you. Thank you for coming in.
Angela Cristiano is a geneticist who also suffers from the same disease in its mildest stage.
Your parents are both.
She's what's known among scientists as a gene hunter.
Your father's health?
Today, she's investigating Margaret's family background and gathering her DNA. Margaret's sample will be compared to other DNA samples that Cristiano has obtained from around the world. Cristiano's first find came when she tracked down a rare form of the disease to isolated Pakistani villages. With the assistance of local doctors, she was able to gather DNA samples. But to identify and map the gene, she needed to compare it to a known structure of DNA.
I was at a meeting about a year ago and someone was giving a lecture on hairless mice and happened to show a picture of one as a baby when it was just losing its hair. So it still had some hair, but it had lost some. And it struck me at that point that it bore some resemblance to the people in the village in Pakistan.
When Cristiano compared the gene structure of the mouse to the Pakistani DNA, she found the first gene ever linked to hair loss. It is possible that one day, all types of baldness could be cured by genetic treatments. But some people are asking if these remedies are too drastic a measure for cosmetic purposes. Public skepticism has translated into a lack of research funding.
For me personally, I don't see the big problem with attacking the same problems we've been looking at for years, just using genetic weapons instead of cosmeceuticals. The whole reason for treating wrinkles and aging and chemical peels and Botox injections, facelifts, it's different approaches to the same problem, but really, now we're just going to be going at it from the root. So why people hesitate to apply genetic therapies to the same things we've been working on for years is beyond me.
Cures for wrinkles and balding would be minor triumphs compared to other possibilities. Many are convinced that gene therapy will be the most important medical breakthrough of our time. Dr. William Hasseltine is betting on it.
This technology has the power to transform the human body by drawing upon what we do naturally, repair ourselves, restore ourselves to normal function when we're damaged by disease, trauma, or the ravages of time.
Biotech companies like Human Genome Sciences plan to usher in gene-based drugs for the coming millennium. Predictions are that genetic technology will have a greater impact than the Industrial Revolution, and it's happening fast.
My mentor, Wally Gilbert, worked out the first DNA sequencing reaction, and actually working with him and some of his students, I sequenced the first piece of unknown DNA, okay? And it was a very short piece. It was about 150 units long. And if I remember right, it took us about 3 months to get those 150 letters. And we were very proud of ourselves. That was, I think, in 1977. Today, we do 30,000 of those reactions, which are 3 or 4 times as long a day. So it's an acceleration of almost 1 million-fold in speed.
Inside these freezers rest more than 2 million samples of human genes. Each time HGS isolates a specific gene and discovers a medical use for it, the company applies for a patent. They hope their patented gene material will lead to a new and profitable treatment.
What you're seeing is technical synergy. As we put together more and more tools, they feed on themselves.
It's a scientific gold rush, with genetic claims being staked. To date, HGS has filed for the patents to over 2,000 genes. All of them hold the promise of new cures.
We take our inspiration from what people's needs are. People need new blood vessels. One of the things that happens when you get old, to everybody, is their blood vessels run out, they wear out, like other tissues wear out. And in some people, it happens more rapidly than others.
43,000 people suffer and die from vascular disease every year. One of HGS's latest discoveries is a gene called VEGF2 that helps the body grow its own bypass. Not all gene therapy involves a permanent genetic alteration. Some gene-based drugs stay active for only a few weeks, but that's enough time for the treatments to work.
The concept is using genes to regenerate tissues. That is a new concept. 3 or 4 years ago, if you thought about how you use genes, you'd say, well, you'll use genes to replace genes that are broken at birth. You won't use genes to supplement what normal people do. So it's a new concept, and that's always attractive. We found this gene just 2 or 3 years ago, and in very short order, we're able to demonstrate that it has the potential to regenerate new blood vessels, and now it will actually be tested.
HGS has teamed up with Dr. Jeffrey Isner at St. Elizabeth's Medical Center in Boston. Isner developed the revolutionary new gene therapy being used today on patient John Scanlon. 90% of his arteries are blocked. This experimental procedure is his last chance.
Well, I get angina pain constantly. I wear the nitro patch 24 hours a day. I've been on oxygen for a year, a little over a year now. And there's something that has to be done, and this seems to be the answer, I hope.
The surgeon injects the genes directly into the heart muscle at exactly the site where the arteries are clogged. The genes code for the protein VEGF, or vascular endothelial growth factor, which helps generate new blood vessels.
The injection. Okay, Daryl, this is the gene. There will be a little bubble first, I think.
Within 8 weeks, the doctors hope Mr. Scanlon's heart will start to grow its own new blood vessels.
With today's progress with something like this, it's unbelievable. God knows where we'll go. I mean, you know, they started with open heart surgery and the bypasses and stuff like that. Now today they have the gene therapy. If somebody had told me that even 6 months ago before I read it, I'd say I don't believe in nothing.
8 weeks later, 2 new vessels had appeared and Scanlon's angina lessened. If this gene therapy works, it could become a first line of treatment instead of a last resort. Many feel the cures for some of our worst diseases lie in fixing and treating our genes.
Is our death in our genes? And the way I look at it is our life is in our genes.
As our lifespan extends beyond our wildest dreams, the medical scourges that have plagued us for centuries may soon disappear. Most of us die because of the genes we carry. Heart disease, cancer, and age-related diseases like Alzheimer's are all caused by triggers or mutations in our genes. The knowledge of how to correct and replace our genes brings us face to face with immortality.
So there is an aspect of life which is immortal, at least insofar as our planet continues to exist. Now, we ourselves are not attached. Our consciousness is not attached to the immortality of our DNA. But I don't think it necessarily has to remain so. I think that we can give ourselves a much, much longer ride, our consciousness, that is, attached to our DNA.
Mortals have always searched for the secret to eternity. Is it possible that the answer has been within us all along?
Genes are our fountain of youth. That is where we will find what immortality we will find.